Hello, stat students, and welcome back to week 6 of our online stats class. This week, we are looking at adding a couple more tools in our statistical toolbox. We're going to be looking at t-tests in chapter 11 and some other things in chapter 13. So let's go ahead and dive right in and look at practice problem 11-2 for this week. And here's a question. Is a new drug effective in improving heart disease? A sample of patients is randomly selected. Half of them are given a placebo and half of them are given the drug. The improvement in the patient's cholesterol level is then measured, and the average improvement from each group is compared. Perform a hypothesis test to see if the drug is effective in improving a person's cholesterol level. So we're going to do 3 things here, A, B, and C. A, we are going to state both a null and alternative hypotheses. B, is this a right-tailed, left-tailed, or a two-tailed test? And C, is there sufficient evidence at the 5% level to say that the drug is effective in improving a person's cholesterol level? That's where I usually start with our hypothesis, with the null and alternative hypotheses, is looking at what's the question asking us to find. And this is usually where we can get our alternative hypothesis. And so we're looking to see if the drug is effective in improving, if we are seeing an improvement in a person's cholesterol level. So our alternative hypothesis, which again, these can be worded very differently based on the student, based on the person doing the testing, but it's going to be something close to this, where we'll say something like improvement for the group given the drug is greater than, right? We're looking for improvement, so we're looking to compare the group given the drug and the group not given the drug, given the placebo. We want to see if their improvement here is greater than the improvement that we see with the placebo. So it would be improvement for the group given the drug is greater than improvement for the group given the placebo. Okay, so that would be what our alternative hypothesis would be something like that. Or we see improve, P-R-O-V-E, improvement for the group given the drug is greater than improvement for the group given the placebo, or improvement is greater than, or improvement for the drug group is better than, is higher than, is more than, something like that. So then our null hypothesis is usually pretty simple to figure out. Our null is any other possibility outside of the alternative hypothesis. Okay, and a lot of times what I will do is I'll say just copy this and paste it up here, and we'll change it. Improvement for the group given the drug is not, the easiest thing to do would be not greater than improvement for the group. And so what that tells us, not greater than, means it is either less than, or it could also include equal to the improvement for the group given the placebo. So if it's not greater than, it could be the same. Our test could show that the improvement is the same for both the drug and the placebo group. So that's why it's easiest really to use the word not to represent everything else in your null hypothesis. So that gives us our null and alternative hypothesis. That's going to take some practice, a couple of problems to work through to really get down what your null and your alternative hypotheses are, but keep working through these practice problems. So part B then, is this a right-tailed, left-tailed, or two-tailed test? And that is going to be looking at what is our key word that tells us, is it to the right or to the left? And again, we're looking at area under our normal curve, area under our bell curve, just like we did last week as we looked at our norm dist and norm INV. Do we find the area to the left under the curve or the area to the right? So looking for our keywords that we used last week, we see the keyword here is greater than. So greater than would tell us that this is area to the right, or it is a right-tailed test. Okay, so look for those keywords. Greater than, more than, higher than would be area to the right. Less than, fewer than, lower than would be area to the left. And then we do have the idea for a two-tailed test would be area in between that we would see. Okay, so then the question is, part C, is there sufficient evidence of the 5% level to say the drug is effective in improving a person's cholesterol level? So because we are looking at two independent separate groups, they have no commonality between them. This is a person and this is a person, and this is a person, this is a person. Then we are going to use a t-test. Okay, so we have to run a t-test to see if there is really a difference in the means. A t-test just tells us, helps us to look at, is there a difference in the mean? Is there greater than, less than that we see? All right, so to run the t-test, we have to go to data analysis. If you have not installed the data analysis tool pack, you need to go back to week 1 and follow the instructions and getting that installed, or you can Google instructions on installing the data analysis tool pack for Excel. All right, so we go data analysis tool pack, and we are going to look for t-test 2 sample assuming unequal variances. We'll just stick with that one, and the t-test 2 sample for means will be the only 2 that we will use for this chapter. Since there is no pairing between these two, it's not the same person taking both drugs, it's 2 separate people, there is no pairing. So this is just our straight t-test that we're going to use. So we click OK. All right, now it is asking us for inputs, variable 1 range, variable 2 range. So our first variable range is going to be the first set of samples using the drug, and our variable 2 range is going to be the second group using the placebo. Okay, now this box right here, hypothesize mean difference, we're going to go ahead and just leave that blank. We don't need to use that. Now notice over here, as I highlighted these sections, I did include the labels of each column. So I need to make sure I include the labels checkbox if I included them in my ranges here, which I typically should do. My alpha, or our testing level for this class, we're always going to use 5%. We're going to look for the 5% significance level will be our decision-making point that we have. And then lastly, my output range, I actually want to put an output range. Notice when I click that, the cursor jumps back up here. We got to be careful with that. Click down here, make sure we click in the output range box. And then I'm just going to drop it anywhere on the page here is fine. I'm going to put it in F27. It looks like I've got everything in there. Click OK, and it gives us a kick out. Now notice a couple things that we need to check. Okay, it gives us our mean, it gives us our variance, which is leading into our standard deviation. So our average is about 4.5 level of improvement here. Average is about 2.25 here. Now we look at that and we say, well, yeah, it's obviously the average is very different. And that's what a t-test does. A t-test is comparing the average or the mean of each of these, and it's basically telling us if it's different and what possible or what percentage of the time is going to be different that we see. So we notice our mean. The other thing we want to check is number of observations. Notice 24 and 24. If we go over here and count to this point, I have 24. Look down here, it tells us we have a count of 24, which is right. This observation is here, 24. We need to be very careful that you have these correct. It is very easy. A lot of times people will highlight their column of data, check the labels box, and it actually will reduce the number of observations by 1. So you got to be very careful with that. The key number that we're looking at, hypothesized mean difference, degrees of freedom, that numbers that we're not going to get into, t-status here. The one that we're going to look at is either this p-value. This p-value, 1-tail, or p-value, 2-tail. Okay, now how do we figure out which one we want? A 1-tailed or a 2-tailed p-value will give us our answer. And the way that we look at that is, what is our test? That's why we have question B. What is our test? This is a right-tailed test, so under the curve, we're only looking at 1 tail. We're only looking at the tail to the right under the normal curve, so we want to look at that. All right, so now we look at our p-value 1-tailed test. I'm going to highlight that, but I also want to make it a percentage because we are comparing it to 5%, and I'm going to show 2 decimal places. So what this tells us then, this is 1.87%. So this is less than 5%, and that is what we are connecting to, less than 5%. So because that is less than 5%, that tells us that at a significance level of 5%, we reject the null. So any p-value below 5%, we reject the null, meaning there is greater